So we're going to look at the last example. This time you're taking the buffer again from 2A that you calculated, the buffer having an initial pH of 5.01. This time you're going to add sodium hydroxide, or OH minus. And you're going to calculate the new pH as a result. Again, Henderson-Hasselbalch tells us that, well, we know the Ka, so we need to work out what effect adding this sodium hydroxide has on the concentration of HA, weak acid, and what effect it has on the concentration of the A minus. So the first thing to do, work out exactly how many moles of OH minus you're adding. So it's MV over 1000 is, where are we? Yep, 0.1 times by 1 over 1000, and we get 1 times by 10 to the minus 4 moles of OH added. So next, look at the acid that we've got in the solution, which is undergoing dissociation. So we get H plus and A minus. We started off with 0.009 moles of HA, and we started off with 0.016 moles of A minus, the salt. Now, in this case, we are adding 1 times 10 to the minus 4 moles of OH minus. Now, the OH minus is going to react with the H plus, and it's going to remove it because it neutralizes. Okay, they combine to make water. So by adding this amount of OH minus, what we're actually doing is we are taking away 1 times by 10 to the minus 4 moles of H plus. Now the system's going to oppose that change by replacing it. So we get a net, no change H plus concentration. So we need to add, so the position of equilibrium moves from left to right. We replace the removed H plus, but because we're replacing it, we increase the value by this, so we have to increase this value by the same amount. And because we're making it, we are removing it from here, so we take away the same amount from this value. So a quick calculation, we find out that we've got 8.9 times 10 to the minus 3 moles of HA. We've got no change in the H plus, and the change here, we get 0.0161 moles of A minus. Next thing to do, 2, 3, is to convert these into concentration. So 8.9 times 10 to the minus 3 divided by the new volume, which is 51, and then times by 1000 to get into moles per decimeter cubed, and we see that that is equal to 0.1745 moles to the dm, so that's our HA. The concentration of A minus is going to be 0.0161 over 51 times by 1000, and we get 0.3157 moles per decimeter cubed of A minus. Now, if we go to our Henderson-Hasselbalch, we've got H plus equal to Ka times by HA over A minus. Sub your values in, and this is the same Ka as we used earlier, times by, where are we, 0.7145 divided by 0.3157, and the concentration of H plus is 9.618 times by 10 to the minus 6 moles per decimeter cubed. Last step is to plug it into pH is equal to the minus log of that, and we end up with 5.02. So again, move that up. So again, we've added a small amount of OH minus, and the change in the pH of a buffer is minimal.